Good morning, ladies and gentlemen. I welcome you to this class of Cisco Level 1, which is Chapter 10, and which we are going to look at application layer. And we shall look at all the details of it in brief, because it's not new to us. Before I proceed, let me first humble myself for the word of prayer. My Heavenly Father, King of Glory, I thank you for having made me to be here. And King of Glory, I request you to release the anointing to me to be able to give a better explanation to your children. And whoever is going to listen to this video, may him or her receive a total wisdom of understanding and be able, Father, to interpret each and everything that is required in the name of Jesus. Let your mercy and grace be with them. And Father, let the knowledge that will acquire from this, it should not end here, but it should be able to excel them wherever they will to go in their academic life in the name of Jesus. Father, I thank you, I honor you, I bless your holy name, and I turn all the glory to you in the name of Jesus. Okay, let's open up our notes of the CNA, and then this is chapter 10. Let's wait for it to open. So here it is. So we shall be able to begin, and we're saying chapter 10 is an application. The word the application layer, we have been seeing this in ISO or OSI altogether. We have seen it in that company, and it uses a 7-layer architecture or 7-layer stack or 7-layer model for it to move a packet from the source to the destination. So it has 7 layers, and the application layer is the 7th layer. In a TCP/IP model, it is the 4th layer. All these applications will have under it the number of protocols that are being used to enable the communications of end-to-end devices altogether. So we shall proceed to next slide. Then we shall look at the objectives. These are the objectives that we are supposed to cover in the course of this chapter. And then these are the chapters: introduction and the application layer. Introduction, I've already said that already. It's an application layer, which is layer 7 in OSI, and in OSI, and a layer 4 in TCP. And it does different activities depending on which layer depending on which model where it is. Then application layer protocols. We have a number of protocols that are used up by application layer. Here we expect to have DHCP, to have DNS, to have HTTP, to have file protocol, have simple mail transport, and other many protocols that can be used in this case. So this is one of the stack of the OSI and the TCP/IP model revisited, and now we are trying to compare the TCP/IP model, comparing it with the OSI model, which we have been seeing in most of our cases. We know that 3 layers in OSI will be presented or compressed or put together into the TCP/IP model, and it will be called an application layer. So this is an application layer, presentation layer, and session layer, which we call the upper layers in the OSI. So these upper layers, all of them, we call them applications, because these applications and presentation session layer, when you look at it and start the application, you find out that all the activities that the application does, it is repeated in presentation, and again it is repeated in session. Therefore, when you repeat it, it means when a packet is moving, it will be worked on by the application layer. When it reaches here, you again repeat what you have done here, and then it means doing that, it delays the packet to be delivered altogether. And that's why the TCP/IP model came up, for the purpose of trying to remove or to reduce on the delay of a packet within the stack. Application layer, the same applies to it. I'm trying to show you the propagates, the protocols that are being used in an application layer. That is domain name, hypertext transfer protocol, simple mail transfer protocol. We use post office, and then we have dynamic host configuration protocol and file transfer protocol, internet message access protocols. Now we have a DNS system. The DNS name resolve the IP addresses. They resolve the IP addresses to a name. When we talk of a name, we mean www.google.com or www.gameruniv.ac.ug. That's a name. So that name must be having a corresponding IP address on it or on the server. Then the server, when someone types in the IP address, like for example, I can type in 8.8.8.8. That is an IP address of Google. That is www.google.com. So when we use that one there, I expect that the DNS server will have to resolve the number, which is 8.0.8.8.8, getting that, into a website, which is www.google.com. Are we together? So even www.bugema.bugemauniv@sc.ug, it has a corresponding number of the same nature. Are getting that? Depending on which class they are using. Are we together? Therefore, that one will be used for resolving IP addresses into names or names into IP addresses. Then we shall come to hypertext, which we call the HTTP. HTTP is a very good protocol that is being used more especially to locate our web servers, and then it's the one that always makes to retrieve the web pages to appear on our clients on the desktops as we run. Then we have simple mail transfer protocol. It's also one of the protocols that are being used more especially to locate the email server. Are we together? So it's responsibility to find out which server are you looking for. For example, I may be having a server, a Gmail, a server, and then someone is using maybe a Yahoo mail server, and then it's the responsibility of that protocol, simple mail protocol, for it to be able to locate the correct server for you. Then after locating it, and allows you to access your inbox. Then there are other two protocols inside this simple mail transfer protocol that will enable you to open your inbox and be able to read your information. And after reading one protocol, it works in such a way that it will be able to delete the information immediately after reading. Then another protocol, it will not delete, but it will wait for you to order the delete, or you do it at your own cost, at your own time when you feel you want to do it. And these protocols are two that are under simple mail transfer protocol. One, we have POP, which we call the post office protocol. This post office protocol is the one that works in such a way that it allows you to download your emails, read them, after reading, and then they can be deleted immediately without your personal consent or without your consent. Then another one is Internet Message Access Protocol. This Internet Message Protocol, it will also work in the same way. It will allow you to download your emails and be able to read them on your local machine. After reading, it will not delete the message. It will wait until you decide to delete the message. Presentation and session layer. We have a presentation layer, and we're trying to look at it, coding and conversations of application layer data. It will code the information, whatever is coming from the what, and conversing with the application layer. And then it will be able to compress, it will reduce and try to compress the data or the data that is coming from the application layer. And again, it will be able to encrypt the transmission. Are you getting that? So it will be decrypted at the end of the what? Of the transmission, or when it reaches the destination. Session layer will always create and maintain the dialogues between the source and the destination application. So the dialogue, the session layer will always open up a link, a dialogue, communications between the source and the destination for them to continue communicating until each one of them decides to terminate the other. It handles the exchange of informations. People will be exchanging informations as they are moving. Like for example, when you dial up on your phone, someone's number, then it will ring, and then the person receives you. You start communicating. As you talk, she also responds with what you're telling him. So that is exchanging of informations to initiate dialogues, keeps them active, and to restart sessions in case. So it will restart sessions in case if they are proceeding, or they can terminate depending on the user. Presentation and session layers, and they are trying to show you where the presentation and session layers are. And again, on the same note, they still show you some other more protocols that are being used within the application layer together with this presentation layer. So essentially that the protocols that are working on the presentation are the same protocols that are working on the application layer. Are you getting that? That's why they're highlighting this application together with the presentation, meaning that the application layer repeats, the presentation layer repeats what the application layer has done, as I said before. TCP/IP application layer protocols. Domain name service protocol DNS used to resolve internet and names to IP addresses. We have already discussed that. Telnet terminal emulation protocol used to provide remote access to servers and networking devices altogether. So this one here, a telnet is a protocol that will always assist us to access devices on a remote access or devices that we are not directly seated on. When we talk about remote access, we mean we can access a device that is far away from us and we access it remotely on the device which we are seated on. For example, I may be seated on this device and I want to access a device that might be in the register's office, of which the register, the machine that is there, I have to be knowing the name of that machine, I have to be knowing its IP addresses altogether, and then I should know that probably the communication, the connections that I've made can enable me to reach there. So when I reach, the device will always ask me to authenticate. Authentication means checking whether I have the right authority to access the resources on that particular device altogether. So telnet is you to access a device and work on it when you're not directly seated on that particular machine, but the machine is very far. It may not be very far as in London or anywhere. It can even be in your room, but somewhere as long as you're not seated on it. For example, I may access another device that maybe is in the dean's office. It's very near me. Are you getting that? Yes, so that's what we're trying to talk about. Telnet. Bootstrap protocol is a predecessor to the DHCP protocol, to network protocol used to obtain an IP address information during the boot up. So during the boot up, the Bootstrap will always be able to provide the DHCP protocols to be able to get informations that are required by the DHCP. The DHCP host control protocol is used to assign an IP addresses, subnet mask, default gateway, and DNS servers to hosts. That is what it will do, and that's what it always does. We shall be seeing these things practically on the Cisco packet tracer simulation software. The hypertext transfer protocol, as we said before, we said used to transfer files that make up the web pages of the World Wide Web. So it will locate a web server and it will transfer the files that are required depending on the user. The file transfer protocol, FTP, used for interactive file transfer between systems. Are you getting that? So you can download, you can either upload or either download working on different devices or systems that are being used or you are communicating. Travel file transfer protocol, TFTP, used for connectionless active files transfers altogether. So you're used by connectionless. It is not, there is no security in this. This one here does the same work of HTTP, but this is secure and this is not secure. Simple mail transfer protocol is used for transfer of mails, messages, and attachments. We have, I think, discussed that one. Post office POP, used by email clients to retrieve emails from the remote server. Then the Internet Message Access Protocol, IMAP, another protocol for email retrieval. Together. Then we are trying to compare now a peer-to-peer network. So when we talk of a peer-to-peer, actually a peer-to-peer network is the one that gives the maximum security in networking. Altogether. Yes, it's one of the classifications of networks, but we normally use it more especially to personalize or to make one device to communicate with another device. For example, I may be having a branch might be as we have the branch, Bugema University has a branch in Mbale, has a branch in Kasese. So I may need to communicate to someone who's in Kasese, and then I need a direct connection. What I'll do, I'll configure in networking, I'll use what I call VPN, private virtual networks. When I use that one there, it will automatically assist me to be able to read and be able to communicate to that person who is in Kasese without the awareness of my ISP, Internet Service Provider. I'll make a direct connection between me and the other device. That means I will have created what I call a peer-to-peer connection altogether. So it is high security. So you don't expect anyone to either see what you're transmitting or what you're communicating to altogether. So this is exactly what we're trying to look at. So peer-to-peer applications, this is the same thing that we are trying to look at here. They are trying to show you that instant messaging can be sent to one, because instant messaging can be you are in this room and another one is in the other room, then you can be able to send messages together when there is a secure when it is a secure communication without any challenge. Then a P2 applications. With the P2 applications, each computer in the network running the applications can act as a client or a server for the other computers in the network running the application. Are you getting that? So each of them can work as a server, as we know a peer-to-peer network how it works. Are you getting that? So common P2 applications includes eDonkey, we have email, Emule, we have Shareza, we have BitTorrent, and we have Bitcoin, Lionshare, and others. So these are the common applications or apps that can enable us to create a peer-to-peer communications between devices altogether. Yes, so very important. Client server. Client server will be having whereby you have a network, a server in us, and then trying to pick how to download files from that particular server. And that's why you're seeing that this is a phone that is downloading files from the server. Client server, and then you can either download or upload. So the first diagram was showing us how you can be able to download, getting from the server or getting from the internet. Then the second diagram is showing us uploading, getting from your local device to internet. Never is putting it on internet. Getting that as what we'll upload, so it can be done. So well-known application layer protocol and services. Application layer protocol revested. The three application layer protocols involves the everyday work or play, includes HTTP to browse the web. I've already said that. Simple Mail Transfer Protocol, SMTP, to enable users to send mails altogether. Then Post Office POP, to enable users to receive mails. Is it okay? So Hypertext Transfer Protocol and Hypertext Markup Language. Examples will have this. This is a website of Cisco. Are you getting that? So this one here, when you look at this is a website itself. This one here. From here, this is a website. Then this is the file. Index.html is a file that is required. Let's look at it down here. First, the browser interprets the three parts of the URL. The URL is a uniform resolution locator. Are we together? URL, that is a URL. Then we have HTTP. What does it do? That is the protocol that locates now the web page. That's why I told you that HTTP locates a web page. So the web page is from here to here. All together now. Now this is a protocol that is going to be used to locate the web server or web page and retrieve, locate a web server and retrieve a web page. Which web page is this? Which file is index.html? Getting that? So to use that. So this one here is the server name. This is the server name. That's the website that you're going to use. Then the index is the specific file name requested. A specific file name what? Requested. Because the files may be so many of them, but there is a specific file name. For example, I may say www.cisco.com. That's one file name. I'm getting that. That's one website or server. I'm getting that. Then index.html, and then that is a specific. Then I may have another one which is www.bogemauniv.ac.ug. I think that slash might be index.html. So it will pick that particular website when it has run which server are you on. Are you getting that? So it will first locate the server. That is where we say that HTTP will assist you to locate the web server. After locating the web server, and then it retrieves exactly the web page that you need. The browser checks with the name server to convert www.cisco.com into a numerical address, which I told you. Using the HTTP protocol requirements, the sends GET. GET is to get. That is when you are sending, when you send to GET. I get with that. Then we request to the server and ask for the file index.html. When you click on your web server on your website, for example, I click on Google, then it browses. As it browses, it is trying to look at which type of a web page or of which HTML do I need, which web page do I need. I'm getting that. It may be a Gmail. There are so many web pages on Google altogether, a server, on web server called Google. But then, which exactly page do I need? It's, for example, a website is like a magazine. If you have ever studied fundamentals and probably you talked about the web pages, then web pages is like a magazine. The magazine, I can say, we have the website of Bugema University. Under Bugema University, it's not only Bugema University that is there, but inside Bugema University, there are other pages that are inside there. For example, we have School of Informatics, we have a School of Business, we have a School of Health Science, we have a School of Other Educations and others. Are you getting that? All those ones are pages or small page that are within the website of Bugema University. I say that. So whenever I need a content, I may not need the content for the entire university, but I need the content of a specific web page, meaning that I need to locate which page do I need, but where does it appear? It happens or it appears on Bugema University. That means the HTTP, it is its responsibility to locate the server where you belong, depending on your request. And that's why in most cases when we put this on the Google engine, it searches in the entire world and then it brings all the searches depending on the information that are related to what we requested, and then it gives it to us. Then it's upon us to select the best web page or the best content that we need. So using the HTTP, that one has been done, a server sends the HTML code for this web page altogether, depending on what has been done. The browser deciphers. The word decipher is to open the message that has been given or sent to the client. Because when the server sends, it is now sending it when it is ciphered. Cipher is like the word encryption. When I say cipher, I'm meaning the word encryption. Then decipher is decryption. And we know that decryption is done at the destination when the package is being opened by the owner or by the destination device. Are we together? So we shall continue. HTTP and HTTPS. Developed to publish and retrieve HTML pages. That's why we use HTTP and HTTPS. Used for data transfers. It transfers data from the source to the destination because there is a communication between the server and the client. Specifies the requests, stroke and response protocols. So 3 common messages types are used. 1, get. Are you getting that? So you send HTTP to get, which to get what? A web page. 2, post. Are you getting that? So it will be posted. And put. Those are 3 words that will be used. Get is a client request for the data. So say get, it's a client that is sending because you send a person, get for me this. Then post, it is a server client, and put. The 2 post and put are server client, are server responses, because you are responding. So you can put on or you can post. So post and put are used to send messages that upload data to the web server. Let's continue. SMTP, POP, and IMAP typically use an application called a mail user agent. Email client allows the messages to be sent, places received messages into the client mailbox. SMTP sends the mail from either a client or a server. POP receives emails, messages from an email server. IMAP, Internet Message Access Protocol. Email client provides the functionality of both protocols within one application. So you can see that there is a sending email using SMTP. That's when now the message is being sent from the client and then come to locate the email server. When it reaches there, then there is now getting this one here now ready. That means this one here is going to respond to post or put. Getting that? This now they are showing you the action. That this is sent to this. I'm getting that. This one is sending. So the message is sending it. Let me assume that maybe it has taken this. And it is coming here. It is coming here. I'm getting that. Coming to this side. I think that. So it will be put. But this one now has not yet responded. I'm getting that. So it's getting from here to this server. Altogether. This server has not yet responded. altogether. So they're trying to show the action of a simple micro transport protocol with its two types that it works with, that is POP and IMA. SMTP transfer miles. The message must be formatted properly. The message must be organized properly depending on the link that you're using. SMTP processes must be running on both the client and server altogether. If you're using a Gmail, you must be having a Gmail platform running on your computer, and then so that you can be able to connect together. The message header must have properly formatted recipient emails, addresses, and sender. It uses port 25. Post Office Protocols POP enables a workstation to retrieve mail from mail server. Mail is downloaded from the server to the client and then deleted on the server, as I said before. It uses a port 110. POP does not store messages. POP3 is desirable for an ISP because it elevates their responsibility for managing large amounts of storage for their email servers. SMTP and POP and IMA, the server is here, and then you can see send email. The mail is being sent altogether, and then is the recipient in my list of recipients? No. Forwards emails to another server. I'm getting that. Now, if this server checks and find out that that email is not on this server, what it will do, it will forward it to another server where it expected to be located. That's when maybe you have used, for example, you can send an email using Google, and the person you're sending to is a Yahoo Mail or a Rocket Mail, meaning that this message will first go to the web server of Gmail. When it reaches there, it finds that that recipient is not found in his what? In his server. So what it will do, it will forward it to another server. I'm getting that, depending on the address that you have done altogether, and automatically it will be forwarded to the correct server. So this is the same thing that is being done in this altogether. What we have seen the other side, I do not have the recipient list. I have forwarded the email to another server. Then I have a recipient listed. I will place this email in the recipient mailbox. You getting that? Now look at this one here. Is using domain. Is using domain. But this one, okay, here they have not shown us which server is using, but it should be using different what? This one should be using a different server, and this should be different server. I'm assuming this may be Gmail and this may be Yahoo Mail. Are you getting that? That's where such things will be done. MDA accepts the pieces of emails from MTA and performs the actual delivery. Are you getting that? So MDA accepts the packets from this, and MDA receives all the inbound miles from the MTA and places it into the mailbox. MDA can also resolve final delivery issues such as virus scanning and spam filtering and return recipient handling. So it can be able to handle all those security issues. SMTP specifies the email reliability and efficiently. POP enables the workstation to retrieve mails from the mail server. With POP, mail is downloaded from the server to the client and then deleted on the server altogether. IMA, another protocol that retrieves email messages and like the POP when the user connects to the IMA capable server. Copies of the messages are downloaded to the client application. Original messages are kept on the server until manually deleted. We have already said that one. DNS. The DNS domain name service, human legible name, is resolved to its numerical network device addresses by the DNS protocol. As we said before, that every name must have a corresponding number, and when you are searching for such a web page, it will always be resolved. A name can be resolved from the name to the IP address, so the number, or the number can be resolved to the what? To the name. As you can see in this example down here, you can see that this is a name which is www.cisco.com, and now it has a corresponding IP addresses which we call 196.133.219.25. I think that. So this is the IP address of this server, but then of this one here. So it must be resolved. This one here, when you enter this one in the web page, in the web browser, then it have to search to resolve it to this. That's where you see it browsing to check whether it is the correct one or not. If it doesn't, then it will not connect you. So human legible, the same applying here. What we have just talked about, resolving of IP addresses into names or resolving of names into IP addresses. That's what they are trying to show you here. As you can see, that's a client, and then you have the name, the IP addresses here. And we always put the name into the what? Into the web page, into the web address bar, in the address bar. So it is depth here. That is HTTP full colons 2// then www.cisco.com, then /, then might be index.html. I'm getting that to locate exactly which web page you are requesting for. So these ones will resolve these ones here into this IP address. If it finds that it is corresponding, it is correct according to what it has in its database, then it will allow you to receive that web page. That's the same thing that being used here, and then allow me to continue. DNS server stores different types of resources, records used to resolve names. Are you getting that? It contains the name, addresses, and type of records. The record type are A, an end device address, NS, an authoritative name server. Are we together? Authorized server now. Ccna, the canonical name for an alias used when multiple services have the single network addresses, but each service has its own entry in DNS. I'm getting that. So you may be having different services that you are going to use. For example, you need to connect on Bugema University altogether. You know, if you need to connect on Makere University or Ndeje. These are 3 services being done. So the DNS has that capability, which you call the CNAME, and then to look at all those and be able to connect you to the correct web pages that you have logged in or that you need to contact. MX, Mile Exchange Records, maps the domain name to a list of Miles Exchange servers. So MileX will be able to locate different mail servers that are located depending on how people are communicating and where they have their emails. Enables to resolve the name using its stored records, contact, and other servers. The server temporarily stores the numbered addresses that matches the name in a cache memory. So a cache memory is a temporary memory that always will keep these addresses for a short period of time. In other words, is non-volatile. It works when it is still active or being used. Windows IP config stock display DNS displays all the cache DNS. So if you enter this command in the command prompt, this one IP config stroke display DNS. It will display all the cache memories that you have in your what? In your that you have ever visited. That is when you say IP config altogether / display DNS. So DNS hierarchical. The DNS hierarchical is the range depending on the server location. For example, you may have, you can look at www.bugemauniv.ac. Are we together? AC is representing the organization, and .ug, it is now representing under which country this organization is formed. Are you getting that? So that is a hierarchical DNS. Hierarchical DNS. Are you getting that? It is increasing. So if it is another one may be, for example, an organization. It may be www.uganda.ac.org or RG. I think that this means that that's an organization. altogether. But probably it is located either in Uganda, might be .ug if it is added. So this is a hierarchical what? That's what we are calling a hierarchical what? The country have to be identified. For example, have a level domains. AU is Australia, CO is Colombia, COM is business or an industry. You're getting that? So it can be business, like for example, you can talk of www.google.com. That is an organization, or that is a business or an industry. I'm getting that. So it is a business code of extension. Then we have IP, that is Japan. JP, that's Japan. Or R, that's a non-profitable organization. As I said before, that's a non-organization, non-profitable what? Organization. Now to get a link, for example, UN, or you can talk of United Nations High Commission for Refugees. Is it, you can talk of Red Cross. I think that those are NGOs, they are non-profitable companies. So their hierarchical DNS will extend, and always the DNS will have the capability to handle such challenges or services. NS lookup, operating systems utility called NS lookup, allows the user to manually query the name servers to resolve a given host name. Utility can be used to troubleshoot a name resolution issues and to verify the correct status of the name server altogether. So you can verify it by putting www, and then you can verify and get that. Dynamic host configuration protocol, DHCP, allows the host to obtain an IP addresses dynamically. So DHCP servers is contacted and address requested, chooses the address from the configured range of addresses called a pool, and release it to the host for the setup period. The DHCP used for the general purpose host such as end user devices, and static addressing is used for the network devices such as gateway, switches, and servers and printers. So the DHCP is a protocol that is responsible for administering our addresses, or assigning of IP addresses into the entire network, depending on the network administrator. Or sometimes there are some devices that can receive manually. For example, we have a server, we have a printer and switches. For them, they don't send requests. Therefore, the DHCP cannot be able to use them. What you do, you assign them manually. Dynamic host configuration protocol, as you can see here, it can be used on wireless and it can be used on wired. Then we have DHCP discover. You can discover the DHCP, that's the DHCP client, trying to discover the server where it is. And then when it locates it, then the offer will be given and automatically acknowledgement will be accepted. FTP allows the data transfer between the clients and servers. FTP client is an application that runs on the computer that is used to push and pull data from the server running an FTP demo. Now, we said push and pull. Push, that means you're putting online, or pull, then you're downloading. So push will be used for uploading and pull will be used for downloading. To successfully transfer data, FTP requires two connections between the clients and the server, one for the command and replies, the other for the actual file transfer. So the requests will be done. The client will be able to send a request and receipt. The client will be able to send control connections, I think that, and then data connections will be put in place. So the server messages blocks. The client establishes a long-term connections to the server. So there is a long-term connections that is opened up by the session layer or SI altogether, or either transport layer using the TCP. So the long communication is going to be done depending on the connections between the server and the client. After the connections is established, the user can access the resources on the server as if the resource is located on the client host. So when after the client has establish the connections between the server, then he will access the messages or the data as if it's directly on the real server. So the server messages block, then the copies will be now transferred from the server to the client or from any device that you have accessed for you to get whatever you want. The message here around the world. The Internet of Things. Internet of Things means that we expect that within, might be in time to come, or nowadays, we expect most of the devices to be communicated. And we expect that all the devices can be able to communicate online. For example, we have got now the cars we have car mobiles that are being monitored online, that whatever it will be, you can be able to access it and see it wherever it is. We have now look at houses. Houses can also be monitored wherever you are for security purposes, and you can be able to monitor. That is the Internet of Things. Then you can look at even our shoes and even balloons and other more devices can also be connected, and this is what I call Internet of Things. For example, most vehicles in modern companies, in modern world, or in modern countries, you find out that they no longer use traffic. They use these lights to be able to direct people and to show them what they're supposed to do, and even locate them where there is a free parking yard, and then they'll be able to locate it. So Internet of Things looks at all the things being controlled in one point without movement of what? Of people. So we have the message travels through the network. So how the network, the messages travels into the network, we'll have to look at the applications, both transport layer and then internet. So the packets will continue growing depending on which layer it will be passing through altogether and where it goes. The same applies to this one here. This is the same thing that will be done, and here it is showing us, because when it reaches here, it segments it into a number of, depending on the packet. If the packet is too big, then it divides it into the numbers, and then it gives them what? Numbers, so that it can be able to carry it in case if the packet is too large for it. Segments will still be continuing, and transport layer messages segments to the internet layer. So it will be divided into the internet layer. So the same applies here. As the frames are being divided, the internet layer creates an IP datagram or packet. The packet includes the source and the destination IP addresses. The packet is passed to the network access layer altogether. So getting the data through the internet work. So how do these frames now be able to pass through the what? Through the networker layer or the networker model altogether. So this is the process that it undergoes for it to be able to reach it. At the end of the device, the service port number directs the data to the correct conversation. Are you getting that? So it will direct it to the correct port, as you can see. So this marks the end of this chapter. I thank you for your listening, and I believe that you guys have understood what we have discussed. May the good Lord keep you and bless you. May you allow me to end here for today.